Hello friends, welcome to lecture number 33. In today's class, we'll study about magnetic field at the center of a circular current loop. As you can see, I have considered a circular loop where the current is flowing in the clockwise direction. Because of this circular current loop, what will be the magnetic field at point P that we need to calculate? This comes for a 3-mark question in your CBSE. Okay, here also we will use your Biot-Savart's law in order to explain this. Okay, so this circular loop is having a radius r. So r is the radius of the loop. Okay, now I will consider a very small current element, and that current element is dl vector, and it should be along the current direction. Okay, now due to this dl element, what is the magnetic field at point P? How can you find out? I can find out using Biot-Savart's law. So I can write using Biot-Savart's law. Biot-Savart's law, we know dB vector will be equal to mu naught I divided by 4 pi. I is the amount of current which is flowing in the loop. dl vector cross r vector divided by r vector mod cube. Okay, now it is quite obvious, if this is my radius vector, and this angle will be 90 degree. Okay, so the angle between dl and r is 90 degree. So therefore sin 90 will be how much? Sin 90 degree is equal to 1. Okay, so if I open up the cross product, then what I will have, dB will be how much? dB vector will be equal to mu naught I divided by 4 pi dl r, sin 90 is 1, that is gone, divided by r cube. Okay, so if I cancel it out, then I am left out with r square. Now this dB is the magnetic field at point P due to a small current element dl. But if I want to find out what is the total magnetic field due to the total current carrying current in the loop, for that what I have to do? I have to integrate it. Okay, so integration dB will be equal to mu naught I divided by 4 pi, okay, and r square. These everything are constant, okay, for which I have taken outside the integration dl. Okay, now integration dl will be the circumference. Okay, since integration dl will be 2 pi into r. Okay, so let me substitute here. If I substitute, dB integration will give me b. B will be equal to mu naught I by 4 pi r square into 2 pi r. This r gets cancelled out, pi also gets cancelled out, and we will left out with 2. So what we have, the magnitude of the magnetic field at point P due to the current loop will be equal to mu naught I divided by 2r. This is the magnitude. Okay, now you see here we have considered only one current loop. Suppose we have having capital number of turns in this coil, we will have capital N number of turns. Then what will be the magnetic field? So if the coil has capital N number of turns, then B will be equal to how much? B will be mu naught Ni divided by 2r. Okay, so this will be the magnitude. Now we have found out the magnitude. What about the direction? We can find the direction. Find the direction of the magnetic field using a law which is called your right hand rule. We can find the direction using right hand rule. Okay, now what does this rule tells us? Right hand rule. Follow. Now it tells us that, you see here in this case the current is moving in the clockwise direction. You curl all your 4 fingers in the direction of the current. Then see what is the position of the thumb. It is quite obvious in this particular case, when the current in the loop is in clockwise direction, your thumb is into the plane of the paper. Therefore, the direction at of the magnetic field at point P is into the plane of the paper. Okay, and that we got it from right hand rule. So what does this right hand rule tells us? That if you are having, suppose you are having a current carrying loop, suppose I am having a current carrying loop in this manner, this is the loop, okay, and this is another one. So this tells you that this is the current carrying loop. You will find now that the current is flowing in this direction. Suppose your current moves in this direction, that means your clockwise, in this direction it moves. Followed? Then what should be at the center? What should be the magnetic field? If you see, curl all your four fingers in the direction of the current and thumb is into the plane of the paper. So it will be cross at the center. Now if the same thing I will do, but here the current will be moving in your anti-clockwise. Suppose it moves in anti-clockwise direction. Okay. So here in this case the current is moving in this direction. This is the direction of the current, anti-clockwise. So what will be at the center? It will be the thumb is pointing away from the plane of the paper. That means a dot. At the center you will get a dot, the magnetic field direction. So this is how you can find the direction of the magnetic field using right hand rule. Okay. Now if you see here, a very interesting thing comes out of this. If you make a note here, a very interesting thing comes, that your current loop, we can say here that your circular current loop acts like a bar magnet. It acts like a bar magnet. So let us see how it is. Okay. Now suppose, again I will draw it. I am having a current loop, okay, and in this I will find the direction of the current is in the anti-clockwise direction. So it is quite obvious that my magnetic field is above the plane of the paper. Okay. So if I want to draw a bar magnet, it will be something like this. I will draw a magnet in this form. Okay. And this will be your north pole and this will be your south pole. Okay. Whereas if I consider a loop, and here the current carrying loop, the current is in the clockwise direction. Suppose this is in clockwise direction. Okay. If it is in clockwise direction, then I will consider a bar magnet. Which is of this. Here this will be your south pole, this will be your north pole. Okay. And what was the direction? The direction was in the clockwise direction. Okay. Followed? Now how can I say that yes, it behaves like a bar magnet? If we find the magnetic field lines of this circular current loop, then if it is similar to that of the bar magnet, then we can say that. So let us see how the field lines will be. Suppose I am having, again I am drawing another loop here. Here you will see the current is moving in this direction. Okay. It is basically anti-clockwise. Then what will be your magnetic field lines? At the center it will be away, and as you go on, it curves like this will come out. Okay. Fine. It has curves of something like this. These are the magnetic field lines. Followed? And what will be the direction? This will be away, right? This will be away. They will be joined. Okay. Fine. Now why is it so? Because you see, from the right hand rule we know that if the current is in anti-clockwise direction, the thumb is above the plane of the paper. That's why the field lines will come out of it. And if you compare these field lines with a bar magnet, then it is quite obvious that the bar magnet will be something like this. This is the bar magnet, and this has to be the north pole and this has to be south pole. So the field lines of the bar magnet and the field lines due to the current carrying loop, both of them are same, for which we can say that a current carrying loop behaves like a bar magnet. Followed? So now let us do some problems which usually comes in the exam. Okay, let us go for first question, problem number 1. Here you are given with a semicircular wire. You have taken a semicircular wire, okay, and at the center point P, and the current is moving in this semicircular wire as current is in this direction. Okay, this is the point P and the radius of the semicircular loop is R. Now it is asking what is the magnetic field at point P. Find out the magnetic field at point P. That means we have to find out the magnitude as well as the direction. Okay. Now if we go for the magnitude, we already know that the magnetic field due to a current carrying loop is how much? Mu naught I divided by 2R. But this is not a full circle, half circle. So the magnetic field has to be half of that. So divide by 2. So how much it will be for a half circle? Mu naught I by 4R. Okay, this is the magnetic field. Now the question comes, what about the direction? See here the current is moving in your clockwise direction. So if you according to right hand rule, your thumb is pointing into the plane of the paper. Therefore at point P the direction will be into the plane of the paper, which is represented by a cross. Okay, the first question. Let us go to the second one. In the second question it is given that there are two loops, two semicircular loops, one in this manner, okay, the other one in this manner. There are two loops which are given, they are joined in this fashion. And what about the current? I amount of current flows in this direction, here, here, here and here, and this is the center of the loops. Okay, at point P it is asking what is the magnetic field. It is also given that the inner loop has a radius R and the exterior one is having a radius of 2R. And it is asking what, find out the magnetic field BP at point P. Magnetic field at point P. Okay. Now in this problem you have to understand, first you have to understand that the straight line portion, these portions, they will not contribute. Why? They will not contribute because my DL and R, what is the angle? What is the angle between them? The angle between DL and R is theta is equal to 0 for these two parts. Okay, so sine 0 is how much? It will be 0. Okay, so for which these part will not contribute. Then what other parts are left out? You see there are two semicircles are left out, semicircles. So one is in the inner circle the current is going in clockwise, whereas in the outer one anti-clockwise. So it is quite obvious that the magnetic field produced, they will be in opposite direction. Fields will be in opposite direction. It is quite obvious. Now the question comes that which one will dominate. You see here the inner circle radius, because we know that the magnetic field is inversely proportional to the radius. Okay, so here for the inner circle the radius is less. If the inner circle radius is less, magnetic field has to be more. So the direction of the magnetic field will be dominated by the inner circle current. Okay, so I can find out here magnetic field will be equal to, first I have to find out the magnetic field due to the inner circle. Why? Because there the magnetic field is more. How much? Mu naught I divided by 2R. But again you have to divide it by 2. Why? Because this is a semicircle. Okay, so minus mu naught I by 4R divided by 2. Again this is the outer semicircle, that's why divided by 2. So this comes out to be mu naught I by 4R minus mu naught I divided by 8R. Okay, that comes out to be mu naught I by 8R. Now who will dominate the direction? Direction of the, what will be the direction of the magnetic field at point P? It will be dominated by which term? This term. Okay, the inner circle. This one will dominate. And here what it moves? It moves in clockwise direction. So where is the thumb pointing? It is pointing into the plane of the paper, for which at point P it will be crossed like this. Clear? Now what will be the direction? It will be like this. I hope the second question is clear. Now let us move to the third question. In the third question, what it is given? In the third one, the wire, it is an infinite wire, and it is bent in a particular fashion. So let me show it. It is straight like this, then it is bent here, and from here it moves, and it is infinite. Okay, so basically, and it is asking at point P what is the magnetic field at point P, and what is the radius of this semicircular loop? It is R, capital R. And what is the current direction? It is in the direction of the current. I amount of current is flowing. Okay, now it is asking, due to this whole configuration, what is my magnetic field? That I have to find out. This basically, this question can be divided into three parts. First part is this one, magnetic field due to a semi-infinite. I call this as a semi-infinite wire, and then due to the loop, and this is the third part. This will be the third part, and it is quite obvious. This straight line, this portion, will it contribute? This portion will contribute? No, this portion will not contribute. Why? What is the reason? Because the angle between DL and R will be 0. So sin 0 will be 0. So this portion will not contribute. Now who are going to contribute? This portion will contribute, and the semi-infinite wire will also contribute. Okay. Now let us see whether the magnetic fields are going to be added or subtracted. You see, for the semicircular one, the current is moving in the clockwise direction. It is quite obvious. My thumb is pointing into the plane of the paper, for which I can tell the magnetic field to be into the plane of the paper. Now what about the semi-infinite wire? The current is moving up. So you see, in this direction, the magnetic field is going to come out. And this side, the magnetic field will be into the plane of the paper. This is into the plane of the paper. This due to semi-infinite, it is also into the plane of the paper. So finally, the magnetic fields will be added, and the direction at point P will be into the plane of the paper. Is it clear? If you don't follow, please pause the video, rewind it, see it again. Okay, but these are very important points which you need to take care of. So it is quite obvious at point P the direction will be into the plane of the paper, and the magnitude of the magnetic fields are going to be added. Okay, so what will be the magnetic field? B vector will be how much? First, due to semi-infinite wire. If you remember from my previous class videos, we have calculated for a semi-infinite wire using Biot-Savart law, the magnetic field was mu naught I divided by 4 pi r. Okay, again due to the semicircular one, plus mu naught I divided by 2r, but here half circle, semicircle, so divided by 2, so it will come out to be 4r. So this will be the magnetic field. Okay, is it clear? Fine. Then the fourth question we will focus on. In the fourth question, we will see here, we will take a infinite wire, but it is having a thickness. We will take a infinite wire, but this infinite wire is having a thickness. It is having a thickness. This wire, it is infinite. I extend it, but remember, this wire is having a thickness. And what is the thickness of the wire? The thickness of the wire is A. Okay. Now it is asking, what is the current going? The current which is flowing here is I. What you have to find out at point P, what is the magnetic field at point P, and this point P is situated at a distance L, small l, from one of the sides of the wire. Okay, so this usually comes this question usually has a name called as infinite broad sheet. Okay, infinite broad sheet. Followed? So we have to calculate that. For that, we have to take a very small element. We have to take a very small element in this fashion. We have to take a very small element in this fashion. Followed? And that element is having a width of dx. And this dx element is situated at a distance of x from the point P. From the point P, it is situated at distance x. Followed? Now, how much will be the magnetic field due to the small element dx? It will be mu naught di, because in dx element, what is the amount of current which is flowing? It is di. So how do I calculate that di? di amount of current is flowing in the dx. So it will be I divided by A thickness into dx. Okay, this will be the value of di. So mu naught di divided by 2 pi x. Okay. Now if I want to find out the total B net, then I have to, it is quite obvious, I have to integrate over dB. If I have integrate over dB, then I have to integrate over this one also, mu naught di by 2 pi x from L to A plus L. Okay, the limits will be from L to A plus L. Now this will be equal to your mu naught. Instead of di, what I can replace here? I by A into dx. It will be I by A into dx. And what was there previously? It was 2 pi x was there. And what about the limits? L, A plus L. Okay. So let me bring the constants outside the integration. Mu naught will come out of the integration divided by 2 pi A. Okay. And what is left out? Dx by x, L, A plus L. So we know derivative of integration of 1 by x is log x. So it will be mu naught. So current I have left, I. Mu naught I divided by 2 pi A log base E A plus L by L. Okay. So these are the few important questions which are related to this topic and are important from CBSE point of view. I hope everybody must have liked this video. I once again tell you, kindly subscribe my channel because I will be continuing giving such kind of lectures till the chapter number 14. Okay. Any queries you have, you can mail me in the mail ID which is given below. Thank you for your kind patience.